Welcome to lesson 28, integration by substitution, the last topic we have in Calc 1. So we have done a lot of different building blocks of integration. And what's going to happen next is you're going to learn a lot of different methods of integration, how to deal with products, quotients, etc. And the one we're going to start with in this class and end with in this class, but you'll pick up and out too, is what we call integration by substitution. And so it is basically the chain rule in reverse. Okay, so let's start by looking at this function here, the square root of 1 plus x squared. Right? When we take its derivative, we will get 1/2 1 plus x squared to the negative 1/2, and then we'll multiply that by the derivative of the inside, which is 2x. We can simplify that a little bit, and we'll get x over the square root of 1 plus x squared. Okay. So down below here, if I'm looking at the indefinite integral, so I'm looking for the antiderivative of x over the square root of 1 plus x squared, I know that its antiderivative from the work I just did above will be 1 plus x squared plus c, of course. Okay. But we would not have known that if we hadn't just done this derivative. And it's not like we're going to sit here, look at these things and try to just try antiderivatives or derivatives of random functions. So what we really need to do is have a way to rewrite this so that we can work backwards to get to its antiderivative. Okay, and so we're going to use that same method we did when we learned the chain rule of writing inside and outside functions. Right. So let me look at this here. If we were going to integrate, and we had, I'm going to start with 2x on top. I know we had an x in that last example, but this is just going to be a little bit easier. You'll notice when you look at this integrand that you do have a composite function. You have a square root of a function that's not just x, right? So it's immediately kind of giving you those inside vibes, right? Like my inside function, which is u, is 1 plus x squared. So now what we're going to do is we're going to differentiate this inside function. So du dx, and that will give me 2x. Well, look what I have here. I have 2x. So we're going to try to substitute, get rid of the x's in this integrand and turn them all into these u's. 1 plus x squared is already a u. 2x is a du dx. So actually, let's get this 2x dx together and replace it with the du. So what I'm going to do is multiply both sides there by the dx. And so now I have actually this whole piece right here, 2x dx is equal to du. So I can substitute. I have the square root of u on the bottom, and that whole 2x dx is just a du, so maybe I'll write it like this. Okay. And now you're able to actually do the antiderivative of that because it's just u to the negative 1/2. You'll add 1 to the power. And then we'll make the substitution back. What is u equal to? Oh, I added wrong, didn't I? I sure did. It's not 3/2. Let's try that again. Negative 1/2 plus 1 is 1/2. Flip that. That looks a little better, doesn't it? Thank goodness it's the last lesson. Better? Okay. Sorry, my addition skills went out the window for a moment there. The more important part is the substitution, right? So the general idea with u substitution is we're going to pick the inside function to be the u so that we can substitute that in. then we're going to take its derivative and manipulate the dx du portion so that it matches the rest of the integrand. So a lot of times the biggest question is, what do I set my u equal to? And similar to the chain rule, it's kind of like the more you practice it, the better at it you get. But in general, you're going to look for the portion of the integrand that can be considered an inside function. Okay? Like what's under the square root, what's being raised to the power, what's in the exponent of the e or something like that. And whose derivative, maybe off by a constant, is a factor. It's in the integrand as well. Okay? So let's take a look at this first or next example. I have x squared sine of x cubed plus 3 dx. Now, when you look at that, what function seems like an inside function to you? The x cubed plus 3, right? So it seems like a good candidate for the u would be the x cubed plus 3. And then just take a quick look at what the derivative of this would be, which would be 3x squared. And you'll notice that in the integrand, we have an x squared multiplier. That's the sign that you've got the right u. So now I'm going to take my du dx, and actually, just for ease, I'm going to start by automatically in the first step putting the dx on the other side. I mean, I could have done this, but then in the next step, I'm just going to multiply both sides by dx. So why not just start that way? Now, in my integrand, I have an x squared and a dx. And down here, I have a 3x squared dx. So I need to get rid of this 3. So I'll divide both sides by 3 or multiply by 1/3. And now I can see that if I want to substitute for x squared dx, I need to substitute in 1/3 du. Okay. So when I go to rewrite my integral here, the x squared dx, I'm going to put the 1/3 outside because it's a constant. It's taken by so the x squared dx is substituted by 1/3 du, and then I have sine of u. Excuse me. So then I'm going to integrate. Integral of sine is negative cosine. And then I'm going to substitute back in what the u is equal to. And of course, you can check these by just taking the derivative of your final answer, and it should give you your integrand. Okay, let's try a couple more. Now we have cosine squared times sine. Now, both cosine and sine are derivatives of each other. So in order to figure out what the u is, you got to think about which one of these is an inside function. Yes, it's the cosine. Why is the cosine an inside function? Because this is really cosine x squared, right? So it's the inside function. So let's du, give you negative sine x dx. It doesn't look like I have a negative anywhere here, so I'm just going to kick that to the other side. So negative du equals sine x dx. So that part right there is all just a negative du, and the cosine x squared will be u squared. Take your antiderivative and substitute back in what your u is equal to. Okay, one more here. Well, what looks like your inside function? I have 1 minus 2x squared is being raised to a power. Let's see if that will work. When I du, I get negative 4x dx, which is exactly what we have there. So I don't have to do any other manipulation of this. It's just directly equal to a du. And the rest of it, let's make sure I can see it, is I have this u squared in the bottom, so 1 over u squared. Which means I'm going to anti-differentiate u to the negative 2. I add 1. So I'll have negative 1 over 1 minus 2x squared plus c.